You are reading this on a rock we hit with lightning until it learned to count. No, literally. This rock can run a war, play a cat video, and fall in love on a dating app for you. And underneath all of it, it is dumber than a doorknob. The doorknob at least has one job. Everything between the rock and the cat video is a lie. A tower of polite lies, stacked up so you never have to look at the rock. Today, we climb the whole tower, bottom to top. And the lie, at the very top, you're living inside it right now. Down at the bottom, holding the entire thing up, is the dumbest character in this whole story. On. Off. That's the entire guy. He'd introduce himself, but those are his only 2 words. We'll call him Bit. The rock is just billions of him. Tiny switches called transistors, each one flicked on or off by a trickle of electricity instead of a finger. One switch can count to 1. That is the whole resume. To count higher, we line a bunch of them up. And here's the one idea the entire machine is built on. So we go slow. Give each switch a value. The first is worth 1. The next, double. 2. Then 4. Then 8. Each switch, double the last. Now to make a number, you flip some on and add up what's lit. Want 5? Turn on the 4 and the 1. 5. That's it. That's binary, counting with nothing but on and off. 8 switches in a row is called a byte, and it can make any number up to 255. Here's one of them. Grow up. Counting is nice, but you want the rock to decide things. So you wire the switches to vote. That's a logic gate, and is the strict bouncer. Both of you say yes, or nobody passes. Or lets you through if either says yes. Not just flips your answer to the opposite, out of pure spite. Here's the magic, and I'm not going to hand wave it. Feed 2 switches into the right little tangle of these bouncers, and both say yes, starts behaving exactly like carry the 1. The rock just added 1 plus 1. Wire a few thousand of them, and the rock can add, subtract, and compare. Real arithmetic, built out of nothing but yes and no. You don't have to see the wiring, you just have to believe. A pile of yes or no questions is now a calculator. It still only speaks numbers though, so we hand it a codebook. 65 means A. It looks it up and slaps an A on the screen, like that was hard. That codebook grew until it covered every language on Earth, which means you're laughing crying emoji. Also, just a number the rock looks up. Everything you type is secretly a number, so the rock can store, count, decide, and spell. But staring at raw 1s and 0s makes grown humans cry. So we tell the first lie. We throw a blanket over the rock and say, don't worry about that part. Just press the button. Keep your eye on this blanket. We're going to throw a lot of them. That stack is the rest of the video. Bit is keeping a diary about all this. Day 1. Also, ignore the guy in red. Everyone else does. Now, something has to actually do the thinking. That's Chip. He can solve anything you put in front of him, instantly. A real genius. He also has the memory of a demented goldfish. Look away for 1 second and it's all gone, including what a math is. The only language he speaks is machine code. Tiny, dumb orders. Move this, add that. Writing it out by hand would liquefy your brain, so he just runs one loop forever. Grab an order, understand it, do it, instantly forget it, grab the next one. Because he can't hold a thought, we hand him a whiteboard, RAM. A grid of numbered boxes he scribbles on. It's random access memory. He can jump straight to any box without reading the others. A genius who just wrote his own name on his hand, twice. And he does this loop fast, billions of times a second, every step marched in time by a clock ticking quicker than you can picture. People drag that clock to the max to squeeze out more speed, overclocking. He gets faster. He also gets warm. More speed, more heat. This fire is going to follow us for the rest of the video, by the way. We're not putting it out. To do more at once, he clones himself. Those are cores. Now it's a group project where every member has amnesia. All these dumb parts would brawl over the same toys. So there's a manager, the operating system, and it's the only thing stopping 40 programs from grabbing the printer at once. And look, that manager is just another blanket, thrown over all the messy hardware so you never see it. The tower's 2 layers tall now. Keep counting. Even now, you'd be writing those dumb little orders by hand forever. So we throw the biggest blanket yet, a programming language. You write something almost like English, and a translator turns it into the rock's baby talk for you. 2 kinds of translator, and programmers will fight you over them. One translates your whole program up front and is strict about it, fast, unforgiving. The other translates it live as it runs, slower, but lets you mess around. That's the whole personality difference between languages. Inside your code, you keep things in variables, labeled jars. A name on the jar, a value inside. Mostly so Chip stops forgetting his own to-do list. Now watch the rock lie to your face. Ask it for 0.1 plus 0.2. It answers 0.3. And then a little landslide of zeros and a 4. It's not broken. The rock can't write some decimals in binary any more than you can write 1/3 in decimal. It goes on forever, so the rock rounds and a sliver leaks out. Sounds harmless. That exact leak has lost banks real money and helped throw a missile off course. Round carefully. Sometimes a jar doesn't hold a thing. It holds the address of another jar, a pointer. It's how two parts of a program can share the same thing without making a dozen copies of it. A note that says, the good stuff is over there. When a program needs room, it borrows memory and is supposed to give it back. Chip, of course, forgets. So the borrowed boxes pile up until the machine chokes. That's a memory leak. Friendlier languages just hire a janitor to follow him around cleaning up. She does not get paid enough. 3 blankets up now, and the rock is so far down nobody can hear it screaming. Which is the whole point. But all this stuff we're storing, we should probably organize it. Throw your stuff in a row of numbered lockers, and you've got an array. The win, jump straight to locker number 5, instantly. The catch. Programmers start counting at 0, for reasons that have started actual arguments. 2 ways to handle a pile. A stack, like pancakes, the last one you put on is the first one you take off. A queue, like a bathroom line. First to arrive is first to leave. Your undo button is a stack. Your print jobs are a queue. But the real magic trick is a hash map. Hand over a name, a key, and a little goblin instantly throws your stuff onto exactly the right shelf and yanks it back just as fast. No searching. This is how your contacts app finds mom the instant you type it. Be it, naturally, is the stuff being thrown. Connect dots with strings and you get a graph. Your friends list is a graph. A subway map is a graph. And when Google Maps finds your route, it's just walking a graph, trying paths between 2 dots until the shortest one lights up. And a graph that branches out from a single route and never loops back is a tree. You live in trees all day, your file folders, the replies stacked under a comment, the menus in every app. Computing is lousy with them. To actually do work, you bundle steps into a function, a vending machine. Put stuff in, get a result out, use it again and again without rebuilding it. And a function can call itself. That's recursion. Chip between 2 mirrors, spawning a copy, which spawns a copy, which spawns a copy. With no instruction to stop, the copies pile up until they collapse on top of him. They even named the crash after the pile, a stack overflow. The fix is just kindness. Give him a place to stop. A rule that says, okay, that's deep enough, climb back out. Forget it, and the genius politely loops himself to death. Another layer on the tower. We can now store, organize, and process anything. So the next question is the rude one. Is any of it actually good? A recipe, the exact steps you pick to solve a problem, is an algorithm. And your choice of recipe is the difference between instant and the speed of a government website. Say you're hunting one name. The dumb way, check every locker one by one. The clever way, if the list is sorted, rip it in half. See which half your name's in, and rip that half in half. A few rips and you've found it in a list of millions. Same trick your brain uses to guess a number between 1 and 100. How fast a recipe falls apart as the pile grows is its big O. Some recipes limp along, steady. Some panic, double the work, and you quadruple the pain. And some recipes are so bad that to sort a modest deck of cards the worst way, the rock would still be grinding away long after the last computer on Earth has rusted into sand. The entire job of a programmer is dodging that curve. To keep huge programs from turning into spaghetti, you stamp things out with cookie cutters. The cutter is a class, the blueprint. The cookies it stamps are objects, each carrying its own little data and behaviors. And cutters can borrow from each other. A rubber duck is a duck. It gets quack for free, but swaps it for a squeak. Same order, different sound. Someone with a doctorate named that polymorphism and got paid for it. But here's where all of this breaks. Quick, describe a bee. In words exact enough to turn into code. E-aga. You can't. Nobody can. A bee is obvious to your eyes and impossible to write down. So for problems like that, we do something we've never done before in this whole tower. We stop folding the blanket for the rock. We hand it a million examples and let it fold its own. Show it enough bees and wrong guesses, and it slowly stitches together a blanket that just knows a bee when it sees one. Still made of bit, still nothing but on and off. He has questions now? And this is the genuinely unsettling part. Every other blanket in this tower, a human folded on purpose. This one, the rock folded itself, and not even the people who built it can fully lift the corner and read how it works inside. We use it anyway. One blanket left, and it's the biggest. The internet is not a cloud floating overhead. It is thick cables lying on the actual floor of the actual ocean, carrying your texts past actual sharks. Every rock on the network has a street address, an IP, and you never send a message whole. You chop it into numbered envelopes, packets, and the far end staples them back together in order. Lose a few on the way, and that's packet loss. The post office 8 page 47, enjoy the cliffhanger. The whole internet is just rocks flicking on and off at each other across an ocean. Sitting on top of the cables is the web. You type a name, a URL, and a phone book called DNS quietly swaps it for the rock's real number, so you never have to memorize a string of digits and lose your mind. Your browser knocks on that rock and asks politely for the page. The rock says 200, sure, here you go. Or it says 404, that thing you wanted never existed. Same energy as your gym routine. The page itself is 3 blankets in a trench coat. HTML is the skeleton, the words and buttons. CSS is the outfit, the colors and the looks. JavaScript is the muscle that makes the buttons actually do something when you poke them. And behind the scenes lives the database, spreadsheets with a bouncer. Here's the part you need for what's coming. When you log in, the rock takes your typed in name and password and asks the database one literal question. Is there a row where the name and the password both match this? Yes, you're in. No, you're out. Which is exactly the door our friend in red has been waiting for. He's been here since Chip first caught fire. He doesn't guess your password. He types a little phrase that hijacks the question itself. It cuts off the rock's real question early and staples on, or 1 equals 1. And 1 always equals 1. So the question can only answer yes. The door swings open and he walks straight into the admin account without ever knowing your password. That's a SQL injection. Still one of the most common break-ins on Earth. But don't worry, that's never happened before. The fix has been known for decades. Never let what a stranger typed become part of your question. He really hates that fix. And that, all of it, is the tower. A switch at the bottom, blanket over blanket over blanket, all the way up until a rock can show you a cat video and let a stranger walk through a locked door. We've climbed every layer but one. The last blanket isn't in the machine. It's the one wrapped around you. Here's the thought that should follow you to bed. That little switch, on, off, far too dumb to know what it's doing. Look inside your own skull. A neuron either fires or it doesn't. On, off. It's bit. It's been bit the whole time. You're running about 86 billion of them, each one doing nothing but on and off. And not a single one of them has the faintest idea it's part of a you. And Chip, the genius who forgets the second you look away? You have stood in front of an open fridge 3 times tonight. Chip was never the computer. Chip is you, at midnight. Every layer in that tower was a blanket hiding the dumb one beneath it. You have a top blanket too. It's the warm, total certainty that there is one single you in there, awake, running the show. Lift it. There's nobody in the chair. Just switches. On, off, 86 billion of them, agreeing on a story. The story is the one you call me. A computer is a rock we tricked into thinking. You are a rock that, somewhere along the way, tricked itself into thinking it's a someone. Same trick, just warmer and wetter. Chip has one question for you, and he'll forget your answer the instant you give it, so be honest. How many browser tabs do you have open right now? That's your RAM. That's how much your own brain quietly refused to hold in its head. Put the number down below. Chip collects them and immediately forgets them. He's got 9. So do I. So, on, off, stacked high enough to wonder what it is. That was the whole machine. That was the whole video. That was you. Go look at something simple today. A light switch, a calculator, your own quiet little thoughts. And count how many lies are holding it up. On, off, good night.